the first type of patterns you learned from many moons ago was when you used flow diagrams, or you used to call them spider sums. And you remember there would be input numbers on the left, there would be a rule in the middle, and then you'd have your answers, your output numbers on the right. Now, let's quickly complete this one. The first answer will then be 4, and the next one 7, and the next one 10. Good. Now I want to point a few things out to you in this diagram, which you're now going to notice when we use tables as well. What's happening? Plus 3 each time. What do we call that? When something is constantly being added the same amount. Good, constant difference. And the constant difference continues while the pattern is continuing 1, 2, 3, 4, 5, right? But does the constant difference still apply here? No. So how did we get this one? Could we use the constant difference? No, we had to use the rule that's in there. Right, so I'm going to now use the same number pattern, but I'm going to show you what it could look like when it is given as a geometric pattern that you've seen here. It still comes from your normal old diagrams. Okay. So in a geometric pattern, we have pictures. Now this one I'm going to do matchsticks. I'm sure you've seen this pattern numerous times.
Bless you.
These are obviously supposed to look a little more square, but oh well. You can count the matches, right? Now I'm going to do this in a table so that you can get the idea. The first thing that's always in a table is the position of the term in the sequence. So I'm just going to call it picture number, the picture number for now, because picture number would say which number picture is it, how manyth in the sequence is it. So I'll have picture number, this is picture 1, that's picture 2, that's picture 3. Easy. Then we have our output number, which is the number of matches. Okay, so let's quickly count our number of matches. We'll have 4 there, we'll have 7 there, and we'll have 10 there. Does that ring a bell? Look at your diagram. Okay, so the diagram would be the same thing as what this picture pattern would be. What is the constant difference in this pattern? Constant difference, and you'll remember I sometimes call it the tip. What's the tip that we're looking for? The tip, yes. What is the tip?
The tip is plus 3.
3, or just, you can also just say 3 if you want. The tip is plus 3, okay? That's all good and well, and I can use that to find maybe the 4th output number or the 5th output number. But is it going to be convenient for me to find the 50th picture number? So if I ask you, if I continue this pattern up to picture number 50, will you want to go draw picture number 50?
No.
No, I don't want to draw picture number 50. I can work out how many matches I need, not by going and drawing the picture, but rather going and checking for a rule. Now you can see that the plus 3 is not going to apply there, it's not going to work, and that's where I need that rule. The rule that was in your diagram, how can we figure that out? It's quite easy to figure out the rule if we start with the constant difference or the tip. So because I was plussing 3 each time, I'm going to try taking my picture number, your picture number, and timesing it by 3. Let's see what that'll give me. Let me do that in a different color. So if I times this by 3, it gives me 3. How far am I from 4? 1 away. So I could try a plus 1. It worked for the first picture, but that's not enough. I have to check at least one more. Let's see. If I take 2 and I times it by 3, that gives me 6. And if I plus 1, then that will give me 7. So the rule I can say is take your picture number, if it's picture 1 or 2 or 3, times it by 3 and plus 1. And what will you get? 5. You'll get your amount of matches. So now I can apply this to the number 50, and I can say 50 times 3 plus 1. That's what we've done in the diagram before, and that's going to give me 151. So I've worked that out with my rule. You all seem to remember very well. Now, different ways to write the rule. It sometimes becomes quite long to write picture number times 3 plus 1 equals the matches or the number of matches. Then I've taught you in grade 6, you can write input times 3 plus 1 equals output.
X times 3 plus 1 equals 1.
Good. And now we can even shorten that further because we always call the input, it doesn't have to be, sometimes we call the input n. I've seen that in our textbooks as well. Sometimes they like to use a n here or a x. But I would then say it could be n. Let's use n. N times 3 plus 1, and that'll give me my output number. Okay. I'm going to show you 2 more ways to write the same rule. Be the same thing. We could say, like you guys said, if the input is x, we could say x plus 3. It wasn't plus 3, it was times 3 times 3 plus 1 equals y. And then when it comes to our algebra rules, do you remember that you don't have to always write a times? If a number and a letter in algebra is right next to each other, it means you must times them by each other. So this would then be, let's first just put them together. x3 plus 1 equals y. But another algebra rule that we'll learn is that we don't put the letter, we don't put the letter first, we put the number first. So x3, it's just not a nice way of writing it. It reads better when we say 3x plus 1 equals y. So that looks nice and fancy. And that from there is the format you'll put your rules in high school. Okay. So that's why I'm showing you, just to take it a little further. This format is still exact plus. Sorry. Okay, so when we look at this picture pattern, this geometric pattern, we can count the dots. So the first thing you do when you see a geometric pattern is usually input 1, 2, and 3 you can get by just counting whatever you see on the picture. So I'm going to count. There's 1 dot there, there's 5 dots, and this one has 9 dots. And if they gave me the next picture, I could also count that one. By just having these 3, I can immediately see if there is a constant difference. Is there a constant difference?
Plus 4.
The constant difference will be plus 4. And that I can use to get picture 4, picture 5, even maybe picture 6 if I want to go that far. So the constant difference is plus 4. The rule can't be plus 4. Because will that help me get the 100th pictures dots. If I tell you I'm going to draw 100 of these pictures, how many dots will there be in my 100th picture? Then going and saying plus 4, plus 4, plus 4 until eternity is going to take too long. So to figure out my 100th picture, I want to find a rule that goes from the top to the bottom. A rule where I can use my input number to get my output number. It's always convenient to start by trying whatever your constant difference was and times by that. So let's do the rule times 4. Let's start with that. I'm going to put an x there. X times 4. So what is 1 times 4? 4. Okay, that leaves me a little far from 1. What can I do after getting 4? I can minus a 3. And that's worked for number 1. That's not enough. I need to check again. 2 times 4 is 8. And if I minus 3 from 8, I get 5. That worked. If it worked for 2 in a row, it'll work. Then you can check again your next one if you want. So that will give me y, which is the output number. Now that I have the rule, I can answer this question at the end, which says how many dots in the 100th one. So all I need to do to answer this is I need to say, okay, 100 times, because I'm asking for the 100th position, times 4 minus 3. What will that be? It will be 400 minus 3, which gives me